Ladies and gentlemen, tonight's talk is about reaction mechanisms, and this is just going to be part one of reaction mechanisms. We're going to give you some of the basics of it, and then later on in part two, we're going to dive into what happens when we have fast reactions and slow reactions. We'll dive into how to write rate laws and what a rate determining step is. So let's just go over some of the basics here first to start off with. So what is a reaction mechanism? Well, a reaction mechanism is going to be a process by which a reaction occurs. Now, up to this point in chemistry, we've always just written a balanced equation and said, there's your reaction. And sometimes that's true, and sometimes it's not true. So sometimes we can have elementary reactions, and these are reactions that occur in a single step or a single event. Here's a great example of an elementary reaction. We have NO gas reacting with O3 gas, and we're producing NO2 gas plus O2 gas. If this is the reaction, the NO right here collides with enough kinetic energy with the O3 in the right orientation, then we're going to produce NO2 and O2 gas. But sometimes that does not occur that way, and we'll get to that in a few minutes here. So let's talk about a couple other things that we sort of definitions that we throw out there with respect to reaction mechanisms. Molecularity is the number of molecules that are going to participate as reactants in a reaction. Okay, so remember, we do have to have these collisions of molecules. They have to be the right orientation with enough kinetic energy. So we can have what we call a unimolecular, which is just a single molecule reacting, oftentimes decomposing into something else or just changing into something else. We can have a bimolecular, which is two molecules colliding to form products, and this is pretty common. And that was the example that I gave you before. You had your NO reacting with your O3. That would be bimolecular. You have two molecules that are going to slam together and form products. A rare form is what's called a termolecular, and this is where we have three molecules, and they all have to slam together at the right orientation at the right time just to get this reaction to occur, which is, it's a little bit more rare, but it does happen occasionally. So let's talk about really where it gets important here for us, and that is in multi-step mechanisms. Okay, so a multi-step mechanism. This is where you have a balanced equation, and it can be represented by multiple steps. That's why we say it's multi-step mechanism. So multiple steps. So let's say we have this reaction here, NO2 gas reacting with carbon monoxide to form nitrogen monoxide and carbon dioxide gas. Now, so up until now in chemistry, like we've said, we've always just looked at this and said, okay, there's our balanced equation. We're good to go. Okay, so let's take a look at what's going on here, these two elementary steps. So this reaction does, instead of taking place in a single step, it takes place in a two-step process. So we have nitrogen dioxide colliding with nitrogen dioxide to form nitrogen trioxide plus nitrogen monoxide. So we've kind of transferred one of those oxygens over. And then what we have in a step two is we have nitrogen trioxide colliding with carbon monoxide to form nitrogen dioxide and carbon dioxide. You can kind of see where that oxygen in the collision sort of was transferred over as well. Now, we do say, and I'm going to erase some of this off here, that the sum of, sorry about that. Okay, we do say that the sum of these reactions has to match our original reaction. So again, here is our original reaction that we're looking at. And so we have to be able to add these two together. Now, what we can do is, just like when we did in Hess's law, is if we have something that exists as a reactant in one and a product in the other, we can actually cancel it out. So let's look and see here. So we do have NO3 produced here, and then NO3 is consumed there. So that's going to cancel. Now, that's a special type of thing. It's called an intermediate, something that is produced in one step. So NO3 again is produced as a product here, and then it is consumed there. An intermediate does not show up in the final balanced equation, so we're going to go ahead and cancel that out. We also have NO2 being consumed and produced, and we're going to cancel it out. So let's rewrite our equation and sum everything up, just like we do in Hess's law. NO2 plus CO yields NO plus CO2. So if they ask, is this a good proposed mechanism, it would be, because um, things canceled out, and everything summed up to be and match the original reaction. So let's take a look at a sample question now. Okay, so here's our sample question here, and we are proposing that O3 is converted to O2 into two steps. We have our first step and we have our second step. And so first off, they're going to ask us to describe the molecularity of each elementary step. So for step one, we just have one reactant, so this is going to be unimolecular. And for step two, we have O3 colliding with oxygen, so this is going to be bimolecular. Okay, so we got those taken care of. I'm going to go ahead and erase off that. And then we're asked to write the equation for the overall reaction. So I'm going to start with my reactions. I have O3 right there, and I have another one right there, so I have two O3s. On the reactant side of step two, I have a monatomic oxygen, but over here I also have a monatomic oxygen, so those are going to be canceled out. First step, it's used up. Second step, it's consumed, so that's one of my intermediates right there. That's part of my answer for the part B, even though those are labeled wrong. And then looking at my product side, I have an O2 here, and then I have another O2 there. So I'm going to have a total of three O2s, and so this would be a good proposed mechanism, and just the monatomic oxygen would be our intermediate there. So that's a sample question. This is, like I said, is step one of what we're talking about. Step two is going to be, we're going to talk about how to write a rate law based on what we call a rate determining steps, next lecture. And then we're also going to talk about what happens when you have different speed steps, fast steps and slow steps and things like that. That's coming on our next lecture, which will be tomorrow.